similar titles. The first lesson, there's actually going to be like 8 questions on. It's unusually heavily weighted, but I do that because that's probably the easiest one. What you need to know about the nature of exercise physiology is, number one, you need to know the definition of exercise physiology. And what you want to do is you want to emphasize it's the study of exercise responses and training adaptation. Okay. Now, also part of that first question is you need to be able to differentiate exercise physiology from exercise science. Okay? Exercise science is a much broader term, and exercise physiology is just one subspecialty of exercise science. Okay? It's just a subspecialty. So is kinese, so is motor learning, psychology, sports psychology, etc. And you also want to know the term fitness. What does the term physical fitness mean? And here what we're really emphasizing is that it means that you can do what's expected of you on an everyday basis, but you can also respond to an emergency situation. When we use the term physical fitness, obviously it's different for me than it is for someone like you, but basically I can do my job, okay? And they still expect me to be able to do the house, the lawn and stuff like that. Those are kind of the emergency situations. And if push came to shove, if I had to run across the street, I could run across the street, not fall on my face. That's what we mean by fit. For you, it would be a very different level of expectation, but again, it means that you can do the types of things that a 20-year-old is expected to be able to do. All right, the second thing, this is objective number 2, very important. You need to understand why it's more important how an adaptation occurs. Why it's more important to know how an adaptation occurs. And what you want to emphasize here is that if I know how a particular adaptation occurs, for example, how I build muscle, how I get stronger, if I know what it takes, I can better predict and control the nature of the adaptation. In other words, I kind of mentioned this very briefly at the end of class. If I know what your starting point is, okay, and I know you're going to have a compliance of, let's say, 3 times a week, you're going to be doing an all-body routine, and I know that, looking at you, you are primarily an ectomorph, I would say probably in about 3 or 4 months, you're going to add about 2 pounds of muscle, which might be 3 pounds to your overall frame. It's a very predictable type of response with that. But if you're a coach and the guy says, look, I want this guy to put on 15 or so pounds of weight, and I want a good part of that to be muscle, then you really have to know, how is it that I add muscle? How much work am I going to need to do so that most of that weight that's put on is in fact muscle work? What's the best way for me to add these pounds to the frame? All right, the next thing we looked at, this is objective number 3, we looked at the term homeostasis. And we differentiated it from steady state. Okay? We looked at the term homeostasis, and we try to make a distinction between homeostasis and steady state. And we said, basically, homeostasis, we're looking at the tendency of an organism to maintain a constant environment while at rest. Okay? That's homeostasis. You know, basically, it's the body trying to maintain a normal resting level of temperature, metabolism, etc. When you exercise, if the exercise is, let's say, of a given intensity, you're not going to establish homeostasis because you're exercising. In essence, what will happen is, if the exercise is constant, you're going to try to achieve what is called a steady state response. And that means that ultimately, heart rate levels off, breathing rate tends to level off, temperature tends to level off, the body's pH tends to level off. You get this leveling off that occurs during exercise. And it doesn't mean that you're back at rest. It means that your body is now able to match the metabolic demand, okay, with its responses. So your responses have leveled off because now it's adequate for the demand of exercise. The next term is going to apply to both exercise responses and training adaptations, and it's the principle of negative feedback. Okay? If you take a look at exercise responses, when we exercise, you have homeostatic disturbances. When you exercise, your pH will change, your temperature will change, your oxygen levels, let's say within the muscle cell, may temporarily drop. Carbon dioxide levels will be elevated. If you take a look at exercise responses, the nature of the exercise response is to correct the direction of the homeostatic disturbance. So, if you take a look at, for example, my breathing rate, what I'm going to do is, my homeostatic disturbance might be an increase in carbon dioxide. So carbon dioxide levels go up. That's the homeostatic disturbance. The breathing, the increase in the breathing rate is designed to, in essence, lower the carbon dioxide levels. I won't get back to resting, but they are designed to reverse the direction. So my breathing rate, my increased breathing rate, is designed to basically reverse the direction of the homeostatic disturbance. Not that I totally reverse it, but that I'm going in the opposite direction. The same is going to apply to a training adaptation. If I take a look at a training adaptation, it is designed to make a homeostatic disturbance less physiologically disturbing. Okay? Okay, what do I mean by that? Take temperature. If I run in this room, 10-minute mile pace before training, my body temperature might get up to 103.5. But after training, particularly training in the heat, my body temperature, same 10-minute mile, may only go up to 102.5. Why? Because I had training adaptations. If you take a look at it, they're designed to take the homeostatic disturbance in the opposite direction. I sweat sooner. The fact that I sweat sooner, my temperature doesn't go as high. I sweat more. The more I sweat, the less my temperature rises. The direction is opposite. Okay? Okay, and again, emphasizing the term steady state, know that when we get this plateauing, okay, when we get this plateauing during exercise at a fixed intensity, okay, that's the key thing. You know, you're running at the same pace or bicycling at the same pace. When you get a plateauing, that's steady state and it's not homeostasis. Okay, last three questions. These are simpler ones. They're true, false. Basically, you need to know, you need to recognize what is training. How do we define training as opposed to an exercise? How do we find training as opposed to exercise? Remember that training is a systematic sequencing of exercise sessions. And the changes that we see are relatively permanent. Okay, then you're going to have two questions. One, you're going to be given two either homeostatic disturbance, physiological responses, or training adaptations. You have to know what it is. By that I mean, heart rate goes up while you're exercising. That's an exercise response. If your body temperature, if your cell temperature, body temperature increases while you're exercising, that's a homeostatic disturbance. So the way I always say the easiest thing, think of a cell. If this is a change that affects a cell, it's a homeostatic disturbance. So a drop in energy level is a homeostatic disturbance. A change in the pH, homeostatic disturbance. An elevation in temperature, homeostatic disturbance. But exercise responses, tend to think of them as short-term, systemic responses that occur during exercise. What do I mean by that? The fact that my heart rate increases while I'm exercising, that's an exercise response because it involves my cardiovascular system. And if I go one step further, it's designed to deliver more oxygen, to remove carbon dioxide, deliver more nutrients. It's really designed to counteract the homeostatic disturbance. When it comes to a training adaptation, what you need to know about a training adaptation is that it doesn't generally disappear when exercise is over. A training adaptation is relatively long-lasting. It doesn't mean that it's permanent, but it tends to last longer, several days, several months. So if I have an increase in muscle size, that's not a pumping effect. Not that short things that bodybuilders do before they get on stage, no. But if I have an increase in the size of my biceps, let's say over 6 months of training, it may have increased a half an inch and an inch, that's a training adaptation. That's a hypertrophy of the muscle cells. Okay, the next and probably the most difficult section is the neuromuscular, the neuroendocrine responses. No question, this is where people miss the most points. Okay. What you want to know, number one, how does a chemical messenger interact with its receptor? In other words, why can a neurotransmitter, why can a hormone bring about a change in the cell? And it has to do with the complementary shapes of the messenger and the receptor. Complementary shapes, lock and key.
Is it chemical messenger interact with
Yeah,
right?
yeah. Basically, it has to do with the complementary shape of the messenger and the receptor. Complementary lock and key. Okay, then there are going to be two separate questions, even though they're not back to back. One, what does a neurotransmitter do to its target cell? Versus what does a hormone do to its target cell? How does it change the activity? Neurotransmitters, fast acting, that's not the answer. But basically,